Hello everyone, today we are going through some important questions from applications of derivatives. First question, the radius of a cylinder increases at a rate of 1 centimeter per second and its height decreases at a rate of 1 centimeter per second. Find the rate of change of its volume when the radius is 5 centimeter and the height is 15 centimeter. If the volume should not change even when the radius and height are changed, what is the relationship between the radius and height? It is the problem of rate of change of quantity. Okay, so here what are given? That is rate of change of radius of a cylinder is 1 centimeter per second. That is rate of change of radius with respect to time. And it is given that the rate of change of height with respect to time is, it decreases, therefore it is -1. Okay. So therefore, let's write, let R be the radius and H be the height of the cylinder. Okay, then, and V be the volume. Okay, because here we have to find the rate of change of volume, right? So here, rate of change of volume, what is the formula? V is equal to, that is volume of cylinder, pi R square H. R is the radius and H is the height of the cylinder. Okay, so here what is dV by dt? Differentiate it with respect to t. See, before that let's write what are given. See here, that is rate of change of radius, that is dr by dt, that is equal to 1, and rate of change of height dh by dt, that is equal to -1. Okay, now let's differentiate it with respect to t. Dv by dt, that is equal to, pi is constant, then product of two functions, let's apply product rule, r square into dh by dt plus h into derivative of r square with respect to t, that is 2r into dr by dt. Okay, that is equal to, now substitute dh by dt and dr by dt value. So pi into r square dh by dt is -1 plus 2hr into dr by dt is 1. Okay, that is equal to pi into minus r square plus 2hr. Okay, so here we have to find the rate of change of volume with respect to time when the radius is 5 centimeter and height is 15 centimeter. So let's substitute r is equal to 5 and h is equal to 15. Okay, so dv by dt when r is equal to 5 centimeter and h is equal to 15 centimeter, that is equal to, now substitute, r is equal to 5, so pi into minus of 5 square, that is -25, plus 2 into h is 15 into 5, that is equal to, here pi into -25 plus 30, here 15 into 5, that is 75, 75 into 2, 150, that is equal to 125 pi. Okay, so here the rate of change of volume with respect to time is 125 pi centimeter cube per second, right? Centimeter cube, since it is volume, centimeter cube per second. See, next question is, if the volume should not change, okay, if the volume should not change even when the radius and height are changed, okay, if the height and radius are changing, okay, if the volume should not change, if the volume is not changing, so what is the relationship between height and the radius? Okay, what is the relationship between the radius and the height? See, we know that if the volume is not changing, its rate of change of volume with respect to time is 0, right? Because it is not changing, right? That is rate of change of volume with respect to t, that is 0. So here, since volume is not changing, dV by dt is equal to 0. So what is our dv by dt? This one, right? Yes. That implies pi into minus r square plus 2hr is equal to 0. That implies here take pi right side, it will be 0. So we will get 2hr is equal to minus will become plus r square. That implies r cancelled. So 2h is equal to r. So it is the relationship between height and the radius when the volume is not changing. Okay. Look at the next question. The total cost C of x is associated with provision of free midday meals to x students of a school in primary classes is given by C of x is equal to 0.005 x cube minus 0.02 x square plus 30x plus 50. If the marginal cost is given by rate of change dc by dx of total cost, then write the marginal cost of food for 300 students. Here it is given the total cost of food for x students, that is C of x is given, and in this question it is given that marginal cost is the rate of change of total cost with respect to a unit, that is dc by dx. Okay, in some questions it wouldn't be given. Okay, so in this case, see, you remember marginal cost is nothing but rate of change of a total cost with respect to a unit. Okay, so here what we have to find? We have to find marginal cost of food for 300 students. Okay, that is we have to find marginal cost when x is equal to 300. Okay, so first of all let's write total cost for x students. C of x is equal to 0.005 x cube minus 0.02 x square plus 30x plus 50. Okay, then marginal cost dc by dx, that is equal to, differentiate it with respect to x. So here 0.005 into 3x square minus 0.02 into 2x plus derivative of 30x is 30. Okay, then that is equal to, here 3 into, that is 15. So 0.015 x square minus 0.04x plus 30. Okay, it is the marginal cost. We have to find marginal cost of food for 300 students. Okay, here x is the number of students. So here we have to substitute x is equal to 300. That is marginal cost of food for 300 students means what is the marginal cost when x is equal to 300. Okay, so here dc by dx when x is equal to 300, that is equal to 0.015 into 300 square minus 0.04 into 300 plus 30, that is equal to, here 300 square is nothing but 90,000. Okay, so 9 into 15 is 135. So 135 0. So 4 zeros are there, 3 0 cancelled. Okay, so 1350 minus, here 3 4s are 12. So 12, then 2 0 cancelled. Okay, 12 plus 30, that is equal to 1350 plus 30, 1380, 1368. Okay, so rupees 1368, 368. Okay, 1368 rupees is the marginal cost of food for 300 students. Find the values of x for which y is equal to x into x minus 2 whole square is an increasing function. Okay, if the given function is an increasing function, what are the values of x? Okay, so here y is equal to x into x minus 2 whole square, that is x into x square minus 2x whole square. Okay. Then let's differentiate it. That is dy by dx. dy by dx is equal to 2 into x square minus 2x into derivative of x square minus 2x, that is 2x minus 2. Okay. That is equal to, here x is common, so let's take x outside. 2x into x minus 2 into, here 2 is common, let's take outside. So 2 into x minus 1. Okay, that is 4x into x minus 2 into x minus 1. Okay, so here we have to find the values of x, right? So we have to make the intervals. Okay, divide the intervals, that is domain minus infinity to infinity. So here, so for that we have to find the critical points. To find the critical points, we should put dy by dx is equal to 0. Okay. So dy by dx is equal to 0 implies 4x into x minus 2 into x minus 1 is equal to 0. Okay. That implies x is equal to 0. X minus 2 is equal to 0 implies x is equal to 2. X minus 1 is equal to 0 implies x is equal to 1. So x is equal to 0, 1 and 2. Okay. So now let's make the intervals. That is, first is minus infinity to 0. Okay. Then 0 to 1. Then 1 to 2. Then 2 to infinity. Okay. So here next sign of f dash of x. Okay. Here that is dy by dx. Okay. Because here we are putting the values, that is intervals values to x values in dy by dx. Okay. So here sign of dy by dx. Okay, I will write here. Minus infinity to 0, 0 to 1, 1 to 2, 2 to infinity. Okay. Then sign of dy by dx. Then nature of f of x, increasing or decreasing. Okay. Then first of all, first interval minus infinity to 0. Okay. We have to put these values, that is x values, in dy by dx. Okay. So here when x belongs to minus infinity to 0, that means all the values of x are negative, right? So when we substitute here, see, it will be negative, right? So it will be minus. Then what about this one? Here when we substitute whatever values of x, that is minus, so here we will get minus itself, right? So for example, substitute x is equal to minus 3. So minus 3 minus 2 minus 5. So it is minus. Then what about this one? Here also see when we substitute whatever values, that is minus values in x, we will get minus, right? So it is also minus. For example, see, if you substitute minus 3, so minus 3 minus 1 minus 4, or substitute minus 1, it will be minus 2. So that is minus, right? Okay, so minus into minus, that is minus. So here nature of f of x is nothing but decreasing, right? Decreasing. Okay. Then next is 0 to 1. See, if it is dy by dx is less than 0, then function is decreasing. Okay. Then next interval is 0 to 1. 0 to 1, see here, 0 to 1 means the values of x are positive, right? 0 to 1. So here it will be positive. Then what about this one? See, when we substitute the values, 0 to 1 means less than 2, right? Okay. So when we substitute the values of x less than 2, it will be minus itself, right? Because here substitute x is equal to 1, what you will get? 1 minus 2, that is minus. Okay, 1 is not included. Okay, you substitute 0.5, 0 point is included in this interval. So 0.5 minus 2, that is minus 1.5, right? So whatever values you substitute for x that is less than 2 or less than 1 and greater than 0, it will be minus itself. Okay, so this first term is plus and second term minus. Okay, what about third? Here, see, we have to substitute the values of x 0 to 1, right? That means less than 1, greater than 0, okay? Less than 1, greater than 0. See, suppose if you are putting x is equal to 0 0.5, it will be minus 0 0.5. So, it is minus, okay? Then, see, plus into minus plus, right? So, it is increasing. Then, what about 1, 2? Here positive, right? 1, 2 means the values of x are in the interval 1, 2 are positive itself, right? So it is positive. X is positive. Then what about x minus 2? See, here we have to substitute the values of x less than 2 greater than 1, right? Less than 2 greater than 1. For example, x is equal to 1.5. So 1.5 minus 2 is minus 0.5. So it is minus. Okay. Then what about this one? Here we have to substitute the values x is greater than 1, okay, and less than 2. If it is 1, it will be 0. So greater than 1 means that is positive value, right? For example, 1.5 minus 1 is 0.5, right? So it is positive. So plus into minus, minus into plus, minus, it is decreasing. If it is minus, it is decreasing. Minus means less than 0, therefore it is decreasing. Then what about last interval 2 to infinity? See here in 2 to infinity the values of x are positive, right? 2 to infinity, and it is greater than 2. So here it is always positive, okay? In this interval it is positive, okay? And x minus 2. See here when we substitute x is equal to 2, it will be 0. Then greater than 2, it will be positive itself, right? See for example 6 minus 2 is 4. Okay, 6 is included, right? So 2 to infinity means all the positive values and greater than 2. Okay, so here it will be positive. Then what about this one? See here also we have to substitute the values 2 to infinity greater than 2, right? So all the positive values greater than 2. So here when we substitute all the values greater than 2, we will get positive itself. For example, x is equal to 3, then 3 minus 1, 2, 2 is positive, right? Okay, so it is positive. Then plus into plus, that is plus. So here it is increasing. Okay, plus means greater than 0, that means function is increasing. So here we have to find the values of x, right? So when the function is increasing, okay, when the function is increasing, so here when the function is increasing, x belongs to 0 to 1 and 2 to infinity, okay. So f of x is, that is y, here it is y. So y is increasing when x belongs to 0 to 1 and x belongs to 2 to infinity. Okay, these are the values of x. X belongs to 0 to 1 and x belongs to 2 to infinity. Find the intervals in which the function f of x is equal to 3 by 2 x raised to 4 minus 4x cube minus 45x square plus 51 is strictly increasing, second strictly decreasing. Okay, so when it is strictly increasing, what is the intervals? Okay, so here first of all let's write f of x is equal to 3 by 2 x raised to 4 minus 4x cube minus 45x square plus 51. Okay, then let's find f dash of x. Okay, first of all let's find f dash of x. F dash of x is equal to 3 by 2 into 4x cube, derivative of x raised to 4 with respect to x is 4x cube minus 12x square minus 90x, derivative of 51 is 0. Okay, so here it will be 3 into 2 cancelled, so 6x cube minus 12x square minus 90x. 6 is common, 6x is common, so let's take it out. 6x into x square minus 2x minus 90 divided by 6 is 15, right? Yes. Okay, that is equal to, here let us make it in the form of x plus a into x plus b to find the critical points. Okay, so 6x into, here multiply, that is product should be minus 15 and addition should be minus 2. That is 2 points are 3 and 5, right? So minus 5 plus 2, right? X minus 5, x plus 3. Okay, 3, 5 3s are 15. Okay. So here, putting f dash of x is equal to 0 to find the critical points. 6x into x minus 5 into x plus 3 is equal to 0. That implies x is equal to 0. X minus 5 is equal to 0 implies x is equal to 5. X plus 3 is equal to 0 implies x is equal to minus 3. So these are the points. Okay. So let's make the intervals. Okay. So starting from minus infinity to 0. Then 0 to minus 3. Sorry, minus infinity to minus 3. Minus 3 is the smallest one, right? Okay. So minus infinity to minus 3. Then minus 3 to 0. Minus 3 is less than 0, right? Okay. So first of all, we should write a smallest number. That is minus infinity to minus 3. So minus 3 to 0. Then 0 to 5. Then 5 to infinity. Okay. So we divided minus infinity to infinity. Okay. In the intervals. Okay. Then let's take sine of f dash of x. Sine of f dash of x. Here nature of f of x. Okay. Then in this interval, see x belongs to minus infinity to minus 3 means, see all the values of x are negative. Okay, in this interval, that is minus infinity to minus 3. See here, when x is here, here we have to substitute. Okay, so first term is always negative. That is in this interval, it is negative. Okay. Then what about x minus 5? Here also, see we have to substitute the values of x, all negative values, right? So x minus 5, when we substitute x is equal to minus values, we will get minus itself, right? See, for example, minus 5, minus 5, minus 5, minus 10, right? So it will be minus. Okay. Then here we have to substitute the values of x, negative values, that is less than minus 3. Okay. So if it is minus 3, then it will be 0. Less than minus 3 means it will be less than 0, right? See, for example, put x is equal to minus 6. Minus 6 is included, right? Okay, minus 6 plus 3, that is minus 3. So it will be minus. Okay, so minus into minus plus, plus into minus, minus means decreasing. Okay, f dash of x less than 0 means the function is decreasing. Okay, then what about this one? It is strictly decreasing. Okay, then in this interval, x belongs to minus 3 to 0. That means all the values are greater than minus 3, less than 0. Okay, here also the values are minus and it is greater than minus 3. So here x will be minus. Okay, and here x, substitute x is equal to greater than minus 3, less than 0. That means all the values are minus values. So here for example minus 2. Greater than minus 3, right? So minus 2 is included. So minus 2 minus 5 is minus 7. That is minus. Okay. Then this one. See, when we substitute x is equal to minus 3, it will be 0. Greater than minus 3 means that will be plus, that is greater than 0, right? For example, minus 2. Minus 2 plus 3 is 1. So it is positive. So minus into minus, plus into plus, that is f dash of x greater than 0. So it is increasing. That is strictly increasing. Okay. Because here we will not get the greater than or equal to 0. Why? Because these all are open intervals. Okay. So here it is strictly decreasing, it is strictly increasing. Then next interval 0 to 5, that is x belongs to 0 to 5. See, in x belongs to 0 to 5, all the values of x are positive and it is less than 5, greater than 0. Okay, positive, less than 5. Okay. So here the first term is positive. Okay. Then second term. Here when we substitute x is equal to 5, it will be 0. Then less than 5 means less than 0, right? That is for example 4 is included, right? So 4 minus 5, that is minus 1. So minus. So it is minus. So here x plus 3. Here when we substitute x is equal to, these all values are positive, right? So if we substitute any values of x that is positive values, it will be positive itself, right? So it is positive. Then plus into minus, minus into plus, minus. So it is decreasing, strictly decreasing. Then in this interval 5 to infinity, x belongs to 5 to infinity. See here all the values of x are positive and greater than 5. So here first term is positive. Okay. And x minus 5, it is greater than 5, right? So x values are greater than 5. If it is 5, it is 0. So greater than 5 means greater than 0. So it is plus. Then x plus 3. See, if you are confusing, just put the values. Any values belongs to this interval. Okay. So here put x is equal to any value. That here x plus 3. We are going to substitute the values of x all positive, right? So if we substitute any positive values in this x, we will get positive itself. Okay. So it is positive. Then plus into plus, all plus, that is greater than 0. So it is strictly increasing. Okay. Strictly decreasing, strictly increasing, decreasing, increasing. Okay. So here we have to find the intervals, okay, in which the function is strictly increasing. So for first, here increasing, strictly increasing, x belongs to minus 3 to 0. When x belongs to minus 3 to 0 and x belongs to 5 to infinity. 5 to infinity. Then second, strictly decreasing when x belongs to minus infinity to minus 3 and x belongs to 0 to 5. Find the intervals in which the function given by f of x is equal to sin x plus cos x, 0 less than or equal to x less than or equal to 2 pi is increasing, decreasing. So here we have to find the intervals when the function is increasing and when the function is decreasing. Okay. So here also, first of all, let's write. See, it is the interval 0 less than or equal to x less than or equal to 2 pi. F of x is equal to sin x plus cos x. Okay. Then find f dash of x. F dash of x is equal to cos x minus sin x. Okay. Then we will find the critical points. For that, put f dash of x is equal to 0. That implies cos x minus sin x is equal to 0. That implies cos x is equal to sin x. Okay. That is tan x is equal to 1 or cot x is equal to 1. Okay. So what is the value of x? Here tan x is equal to 1. We know that in which angle tan is 1? Pi by 4, right? So tan pi by 4 is 1. And one more, tan phi pi by 4. Means pi plus pi by 4. Pi plus means in third quadrant. In third quadrant tan is positive. Therefore tan phi pi by 4 is also 1. And we have to check whether these values included in this interval. See here pi by 4 belongs to this interval and phi pi by 4 is also included in this interval, right? So therefore x is equal to pi by 4 and phi pi by 4. Okay. So here till 8 pi by 4 we can write. Okay. But x is equal to pi by 4. Tan pi by 4 is 1 and tan phi pi by 4 is also 1. Okay. Then after that, see, let's make the intervals. So first of all, 0 to pi by 4. Okay. Our interval is, see, x is between 0 and 2 pi. Okay. Therefore, starting from 0 to pi by 4, then pi by 4 to phi pi by 4, then phi pi by 4 to 2 pi. Okay. Now we have to check whether f dash of x less than 0 or greater than 0 in these intervals. Okay. So here it is our f dash of x. Okay. Cos x minus sin x. And this interval 0 to pi by 4. Interval 0 to pi by 4. See here 0 to pi by 4 we know that cos x and sin x are positive. Right? Here because it lies in first quadrant. In first quadrant these are positive. And we have to check. See, it is cos x minus sin x, right? So for positive number the cos x should be positive. Greater, right? If cos x is greater than sin x, then it will be positive. Okay, see for example, let's take cos 0. Okay, cos 0 is 1, and what about sin 0? Sin 0 is 0, that is 1, right? Means here it is greater than 0. Okay, cos 0 is 1, sin 0 is 0. We will get 1, that is greater than 0, right? And let's check one more point, pi by 4. Take pi by 4. Cos pi by 4 is 1 by root 2 and sin pi by 4 is 1 by root 2, that is equal to 0. So here we can write in this interval, this f dash of x is greater than or equal to 0. 0 is also possible, right? See here we have got 0, right? When x is equal to pi by 4, this one is 0, right? So here f dash of x, see here if you want, see we can write closed interval 0 to pi by 4 because it is not strictly increasing or strictly decreasing, just increasing, right? So we can make the interval closed interval because 0 is also possible, okay? So here we can write in this interval f dash of x greater than or equal to 0 because here cos value is greater than sin value. Okay, therefore it is greater than or equal to 0. Sometimes it will be same. So in that case it will be f dash of x will be 0. Okay. So after that in this interval pi by 4 to 5 pi by 4. See pi by 4 to 5 pi by 4 means we know that pi by 4 when x is equal to pi by 4 it will be 0, right? Because cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2. So 1 by root 2 minus 1 by root 2 0. Okay. Then let's take x is equal to 5 pi by 4. See 5 pi by 4 means it lies in third quadrant. Okay, because 5 pi by 4 is nothing but pi plus pi by 4. Pi plus means it lies in third quadrant. In third quadrant, that is cos is negative. Cos is negative, sin is also negative, right? So here we will write that is minus sin of 5 pi by 4 is nothing but minus sin pi by 4. And cos of 5 pi by 4 is nothing but minus cos pi by 4, right? So here we will get it is minus 1 by root 2. It is also minus 1 by root 2. So this will be 0. Okay. And here what about cos x? See, so here we have to, let's take 5 pi by 4. Okay, we have taken 5 pi by 4. Then let's take nearby value, that is 4 pi by 4. Okay, so what about 4 pi by 4? 4 pi by 4 is pi, right? That is pi. 4 pi by 4 is pi. So here we will get 0. Okay, don't worry, that is cos pi by 5 pi by 4 minus sin 5 pi by 4, that is minus 1 by root 2 minus 1 by root 2, that is 0. Okay, so here next is we will take, if we take as x is equal to pi by 4 also, it will be 0. So now we will take any number that is near to any between pi by 4 and 5 pi by 4. You know that 4 pi by 4 is belongs to this interval, that is pi. See what is cos pi? Cos pi is minus 1, right? And what is sin pi? Sin pi is 0. See here we will get it is minus 1, right? That means this f dash of x is less than or equal to 0 in this interval. Okay, that is f dash of x is less than or equal to 0 in this interval. So here f dash of x is less than or equal to 0. So here what about this one? See here also, here when x is equal to 5 pi by 4, we know that it will be f dash of x is equal to 0. Okay, and let's take 2 pi. See x is equal to 2 pi, cos x is equal to 2 pi, cos 2 pi is 1. Cos 2 pi is 1. Minus sin 2 pi is 0. So it will be 1. That is greater than 0. Okay. So here, because see here we checked one more point. We have taken one more point, that is between pi by 4 and 5 pi by 4. Because here we have got in these two values 0. Because we have to check whether it is greater than 0 or less than 0. Okay. That is why we have taken one more point. Okay. Here just it is enough to check 2 points, that is first point and take second points, last point, that is 5 pi by 4 and 2 pi. Okay, here it will be 0. Okay, f dash of x will be 0 when x is equal to 2 pi, That is cos 2 pi minus sin 2 pi. Cos 2 pi is 1. 1 minus sin 2 pi is 0. So 1 minus 0, that is equal to 1. Therefore it will be greater than 0. Okay. So here f dash of x is equal to, f dash of x is greater than or equal to 0. So here we have got, in this interval the function is increasing, and in this interval the function is decreasing. In this interval function is increasing. Okay. So here we have to write the intervals in which the function is increasing. That is, so in which interval function is, f of x is increasing when x belongs to 0 to pi by 4 and x belongs to 5 pi by 4 to 2 pi. Okay. And f of x is decreasing when x belongs to pi by 4 to 5 pi by 4. Okay. Show that the function f of x is equal to x cube minus 3x square plus 6x minus 100 is increasing on R. Here we have to prove that the given function is increasing on R. That means the function is increasing for all real values of x. Okay. So for that, first of all, let's write given function f of x is equal to x cube minus 3x square plus 6x minus 100. Then let's find f dash of x. That is 3x square minus 6x plus 6, right? So let's take 3 outside, 3 is common. 3 into x square minus 2x plus 2, right? That is equal to 3 into, see here we can write it as x square minus 2x plus 1, okay? Because see 3 into, here this can be written as x minus 1 whole square, right? X minus 1 whole square, that is 1 square is 1 and 2 into minus 1, okay. So x minus 1 whole square and it is plus 1, okay. That is equal to 3 into x minus 1 whole square plus 3, okay. See here, if any values of x, any real values are substituted for this x, we know that this will be positive, right? Why? Because it is x minus 1 whole square. If you substitute any values of x, that is any real values. See, for example, if we substitute any negative values, that means, for example, x is equal to minus 5. Minus 5, minus 1, minus 6. Minus 6 square will be positive, right? That is 36. Okay, so here, so any real values substituted for this x, so we will get f dash of x is always greater than 0. Okay, so here it is f dash of x greater than 0, equal to 0 will get, right? Yes, if it is 0, then 0 minus 1. Yes, if x is equal to 1, so it will be 0. So no, we will not get to 0 also. That is only greater than 0. Okay. So f dash of x is equal to f dash of x greater than 0 for all real values of x. For all real values of x. That means this function is increasing on R. Therefore, f of x is increasing on R. Okay.